Hello, Sandeep sir. Hello, hello, Sandeep sir. Hello, hello. Am I audible? Hello.
Yes, you are audible.
Okay, Sandeep. Sandeep sir, please allow me to share my presentation because I am unable to share. Sharing is yeah. Thank you. Okay. Good evening to everyone. Today, as we are continuing from the last class, and about the vinyl polymer. Today, we will study about the very known and very popular polymer that is vinyl polymer, that is your polyvinyl acetate. Okay, so this is your in short form they called as a PVA and take the pointer. Okay. And this is known as your vinyl acetate. And this group, okay, this group basically called as a acetate. And this is your vinyl. As I told you, in every vinyl uh, polymer, this part is very common. Okay, the double bond between this two carbon, that is only the vinyl, and this you will find in every vinyl polymer. And this portion known as your acetate. When they will do the free radical, okay, uh, using some initiator, then that will be take your addition polymerization and we will get the polyvinyl acetate. In this polyvinyl acetate, it is manufactured generally by your free radical initiated, or we can follow emulsion, or sometime we can follow the solution polymerization. Emulsion and the solution, these are the two polymerization techniques that generally used for manufacturing of your polyvinyl acetate. Uh, we study about your polystyrene. We know about the polyvinyl chloride. What we observe that maximum your polystyrene or polypropylene that are formed, they are stereotactic or isotactic in nature. They have a very huge crystallinity. But right now, whatever we are about to study, you will find that they are maximum atactic in nature. Okay, due to the more amount of atactic, almost 80% of the atactic present. That is the reason they call as a amorphous in nature. And whatever the commercial grade PVA is available in the market, they are mostly of atactic or amorphous in nature. Simultaneously, it is this PVA is mainly used in the application of your adhesive. Okay, adhesive means this glue. If you see this pictorial diagram, this is maximum polyvinyl acetate used in this market as a glue. Different kind of glue, but this few glue that are available in market that is manufactured from your polyvinyl acetate. Um, and this it is used in the production of water-based emulsion paint. Means the paint that mark currently this water-based emulsion paint means they can be easily mixed. We have not to use any carcinogenic or any harmful solvent. If you put water also, that your paint will be formed and as a adhesive and textile and in paper treatment. So these are your major uses of your polyvinyl acetate. But this polyvinyl have a very strong, I can say they are very less resistant to organic chemicals as like they are easily soluble with any aromatic solvent. Okay. Also in alcohol or ester. Suppose IPA is your one type of alcohol solvent. So suppose if you add a few of your like if you add few of your perfume, because you know in every perfumery you have adding the 40% or 30% is your alcohol, right? So some kind of alcohol or
Hello, ma'am, your voice is not audible. Can anybody confirm if the issue is same with everyone?
Yeah, yeah, her voice is not audible now.
Okay.
sorry, actually here some network issue, that's where I disconnected. Hello, hello. Okay, I think there is some network issue from my side, so I disconnected from this Zoom meeting. So up to what person you have understand or you have like hello?
In
Can
degree class,
anyone?
there is some 30% of alcohol has been ordered.
Okay, okay. That, thank you. So like here. It has a glass transition. The temperature of this PVA is 29 degrees Celsius. The TG value. That is the reason the polymer they become very sticky at temperature slightly above. Means this PVA, if you keep in the room temperature, okay, in the room temperature, also you find this PVA was quite sticky in nature. Okay. The low molecular polymer, which are normally brittle and become gum-like when they are masticated. Masticated means this word we generally use when we do the cross-linking. Okay, when we do the cross-linking, there we have a chances this polymer will normally they are very brittle because you know the TG value is 29 degree Celsius. So below 29 degrees Celsius, they will be the brittle. But when we do the cross-linking and adding some filler to that, they become very soft and like a gum, okay, in the nature. It is leathery, okay. Leathery means, have you ever seen the chewing gum? Okay, how it's look like. You can, if you like stretch it, it will be stretches and it is very soft in nature. So as like that, or this PVA have that kind of texture or that kind of
Uh,
nature.
Excuse me,
Yes,
ma'am. Just
yes.
I joined late. So is it the starting PV only starting point today, or
Yeah,
have
yeah,
you?
PVA. No.
Okay,
PVA is
okay,
the
okay,
starting one.
okay.
Yeah,
Thank you, ma'am.
yeah. So this PVA, it is in leathery and it is very color. Take this. There's a point. Okay, it is leathery and as well as your colorless thermoplastic polymer. It is also thermoplastic that softened at low temperature and is light and oxygen resistant. Means this particular polymer is quite resistant to your UV light and as well as your moisture resistance. And this polymer, as I told, they are atactic in nature and amorphous. That is the reason this polymer are non-crystalline as well as they are more portion of amorphous are there. That's why they are transparent in nature. Then PVA adhesive produce very means as I told you, PVA maximum use the application of PVA in the industry as like a adhesive, okay, or they use that maximum for the application of adhesive. That is the reason PVA adhesive are very clear. Okay, you see if you see the Fevicol, okay, in market everybody see the Fevicals. They are whitish in color. Okay, but if you see the very clear solution, okay, of adhesive, okay, so I have also no knowledge, right, which company they maximum manufacture the PVA, okay, but this PVA adhesive have a nature is what they are very clear hard after curing means when we provide that adhesive after curing they form a very hard film. That film okay, or that covering after the curing process, they are good weather resistance and withstand water. Means suppose you provide that adhesive in your wood or some application, after some time, means after the curing occur, this adhesive that you can keep it in outside for your longer duration of time, then also there is no deterioration of your material. Okay. Next, if some water also fell into that, then also they are quite resistant. Some glue, if you apply that adhesive on that particular material, but when it's come in contact with the water, that adhesive will be come out from that particular attachment. Okay. So in that case, this PVA have a very better resistance to the water as well as grease, oil, or the petroleum fuel. Okay. Additionally, properties are high initial tacky. Initial means that they are very sticky in nature initially. Almost invisible bond line means, as I told you, as they are more amorphous in nature, so they are quite transparent. Means when you put your PVA adhesive on that particular application, it's very difficult to find out. Okay, this there we provide some different kind of adhesive because they are quite transparent in nature.
Ma'am,
Uh,
just sorry to interrupt. So, as you just told that if any polymer is like amorphous, it will be
huh,
more on the transparent side, right?
yes,
So, just let me know if I'm correct. So, in the case of ABS, I have seen most of the ABS products are like white, and ABS is
yeah.
a amorphous material. So, why is that
Sir,
so?
it depends how much amorphous. See, I
Okay.
tell you, this is the amorphous, but amorphous percentage out of 100, it is 40%. Then, if 60% are crystalline, then also you can see the translucent. Okay. If that is depend upon the percentage of amorphous character they carry. Okay.
So if any material is like 60% amorphous, that means 40% is remaining is the crystalline. So in
Yes.
that case, we will call it semi-crystalline.
Yes.
Okay.
And this PVA is, I can tell you, they are 80 to 90% are amorphous in nature, as they have a very random structure. Okay. And due to this bulky group, you can't get a very straight chain. They are quite entangled with each other. They are combined with each other and they give a very random structure. Due to that, this PVA is quite amorphous in nature as compared to like whatever we previously studied about the vinyl polymer. And this have a softening as 30 to 45 degrees Celsius. They are quite like soft in the nature. And they are good biodegradation resistance also. They are not biodegradable. Okay. As well as poor means as I told you, they are very high amount of amorphous content is present. Due to that reason, you will find that mechanical property might be effect over here. Okay, this is a very general observation. We observe that if you have very highly amorphous character is present in that particular polymer, so might be the mechanical properties, okay, right, like your creep resistance, okay, strength of that. Elongation is quite good on that matter, yield strength. So these few of the properties, they are little bit weak on that. As well as the PVA have a very low economically cost as for the market concern. This PVA adhesive, if we are talking about PVA adhesive and copolymer are used as a halt melt adhesive. Current market, if you study that, hot melt adhesive is quite useful in your textile industry and they are quite uh, what can I say, in the demand. Okay, hot melt adhesive in the decoration purpose they are using in the textile for
Ma'am,
application.
any image of
Yes,
that hot
hot
melt
melt
adhesive?
adhesive. Just I have shown you in the polypropylene case. They are come in the stick form, that polymer. You have to put
Right,
in
right,
that
right.
gun. Okay, hot gun will be there. When
Got
you
it.
place
That was the case for PP. But what about polyvinyl acetate?
polyvinyl acetate also, they will make that kind of for hot
Okay,
melt
okay.
adhesive. As I told you, this PVC are quite soft in nature. Okay, that is the reason here it is written that PVC adhesive, it will be copolymerized with the few polymer and that they can use as a hot melt adhesive. Okay, and as a sealant,
Which few polymer you mentioned? Few polymer. Which few polymer?
few copolymer means that can be they can combine with the polymer. I don't know the name of that because this is commercially they can use as for their suitable purpose. So I can't
Okay, so
claim
you mean
like
to say that adhesive we are making through copolymerization kind of, right?
no. If you are
Hot melt
talking about
adhesive we are making through copolymerization.
yes, yes, for the PVA, huh? For
Yeah,
polypropylene
for the
directly you
PVA.
can yes.
And
So
what
for
about PVA? PVA is unsaturated, right?
unsaturated, you
Hello?
are talking about yes,
PVA comes under unsaturated category, right?
yes, they are unsaturated.
Okay, ma'am. Thank you.
Yeah, yeah. And this PVA adhesive as a PVA act as a sealant also. Sealant means suppose if you are joining two like walls in the construction, this sealant they use for joining like two straight parallel and they just want to fill the gap between these two wall. So this sealant they make that the application in fabric fishing, plastic, wood, or ink. So this PVA adhesive have this must act as a sealant also, or they can use in the fabric also, fabric finishing, as well as in the plastic, wood for joining this, and as well as in the ink. So in the market, I found this few of the, I don't know the company, but they still it is available in this directly like super PVA glue. Okay, this is like a glue stick. This is also PVA made of a PVA, and this is the liquid and different categories or different form of adhesive that is available in market as well as PVA have a wide range of application in the coating, adhesive, in the leather, coating and cotton fabric, paper industry, like the carton uh, processing, paper tubes. Okay, in the paper tubes also for the coating purpose, they are using this printing and your office applications.
Ma'am, polyvinyl is having the adhesive property or the chemical which we are
Adhesive.
is having the
No,
property.
adhesive property. Adhesive property.
Polyvinyl
PVA.
itself is an adhesive property. Yeah?
Yes, yes.
And the chemical what we are adding is only for softening purpose or it's like that, huh?
Yes, yes, yes.
Okay, okay.
Yeah. So in this we
Ma'am,
completed the
what is the similarity or dissimilarity? Sorry, one question, please. What is the
yes,
similarity
yes,
and dissimilarity between PV and PVC? Because both are polyvinyl. One is acetate, one is chloride. So, is it
yes.
a copolymer or what is the similarities between?
Oh,
Or
see, this vinyl acetate is the copolymer
okay, and PVC, PVC.
because PVC is also, you can say they are also copolymer, but you can directly get your vinyl chloride. They are not copolymer. Okay?
Okay,
Yeah.
PVC is not a copolymer. Only
No.
PV, polyvinyl. This this one is polymer. Okay,
Polyvinyl
copolymer.
acetate. Yeah.
Acetate, sorry. Yeah.
Because acetate we got from this and vinyl will get. Then we do the compression at high temperature, high pressure. Then we got the vinyl acetate, and there we form polyvinyl acetate. Okay,
Okay.
we will study another one where we use this polyvinyl acetate also. One
Or
another point.
one more, ma'am, doubt. Any example of that copolymerization of PP?
PP.
Yeah, yeah.
Yeah.
Because I seen your one video lecture. It was mentioned
Huh.
that PP having that less thermal stability and less UV.
Hmm.
So yeah, for that we are doing some to get that property. We are doing some copolymerization.
So, sir, that copolymerization that you will do for the PVC for the like UV resistance, so everything. So you have to choose that polymer. Okay, those who have that property of UV stabilizing. Okay, then you do the copolymerization that with that PP. I can't give you like perfect this you can do with the polypropylene. So you will get the UV resistance or the limitation of the polypropylene. You can overcome it. That I
but
can't say.
there will be some substance which we can add through copolymerization in PP, and we can achieve that property. Maybe any example you can give.
Uh, right now in my mind, I have no example on that particular, but I'll look and I will tell you in the next class.
Yeah, why
Okay.
I'm telling you, because PP generally this is a drawback which you mentioned, that thermal stability and UV resistance. But generally we are using PP, so means through polymerization we are using in our automotive grade that bumper. So what they are doing, that I want to know. Maybe you can tell in next
You
class.
can
Yeah.
use, yeah, I will tell you in the next class, or otherwise you can add the additives to that also without doing the
But okay,
copolymerization.
but additive will not act as a copolymerization. It
Yeah,
will be
but
a separate. Yeah.
okay, I'll tell you the in the next class. Okay, if you only want to do the copolymerization, then I also don't know. I'll look into that and let you know about. Okay.
Okay.
Yeah. So here we complete about your polyvinyl acetate. Now we will come towards very similar name, but it is a different kind of polymer that is known as your polyvinyl acetals. Okay, that here you have a acetate. Okay, and here you have your polyvinyl acetal. And for in this acetal, we use this polyvinyl alcohol. After this polyvinyl acetal, we will going to study about your polyvinyl alcohol. Okay. So this polyvinyl acetals we used or by substituting or we are doing the copolymerization of polyvinyl alcohol with some other alcohol or the acetate group. Okay, or we are doing the copolymerization with the aldehyde. Basically, especially your formaldehyde or butaaldehyde. These are the two copolymerization that we do with your polyvinyl alcohol to get your polyvinyl acetal. Okay. So if we do the copolymerization, this vinyl alcohol with your formaldehyde, then we got a polymer that is known as your polyvinyl formyl phenolic. Understand? If we do the copolymerization of polyvinyl alcohol with your formaldehyde, then we get a polymer that is known as your polyvinyl formyl phenolic hybrid. And they are generally used as a adhesive in your aircraft industry. Okay, but if I do, if replacing this formaldehyde with the butaaldehyde copolymerization with polyvinyl alcohol, then we are getting polyvinyl butyryl, and it has a huge application in your automotive safety glasses for the manufacturing of automotive safety glasses. In between these glasses, they form a interlayer. Okay, so there they use this polyvinyl butyryl. Understand, this polyvinyl acetal is divided into two types of polymer, as this polyvinyl alcohol is copolymerized with formaldehyde to get polyvinyl formyl phenolic. Next, if we do the copolymerization with butyryl aldehyde, then we got polyvinyl butyryl. And this polyvinyl formyl that they use as an adhesive in all the aircraft industry. And this polyvinyl butyryl, they use that as a interlayer for the manufacturing of automotive safety glasses. Uh, this polyvinyl formyl is insoluble in dioxide, acetic acid, phenols, or chlorinated hydrocarbons. Okay, so this PVA is that not that much chemically resistant, and they are very prone to this kind of chemicals. Okay, it is this PVF, or we can say this polyvinyl formyl. It is also well known for its excellent heat resistance as well as their dielectric property, and they are mainly used in electrical insulation coating also, as they can use as a adhesive in the aircraft industry. Simultaneously, they are used as a electrical insulation coating also, as they are quite highly heat resistant and they have dielectric properties. Next is your polybutyl vinyl butyryl. They are also soluble in acetic acid, pyridine, or cyclohexanone or ethyl alcohol. And this polyvinyl butyryl is used for the manufacturing of shatter-proof glass. What do you mean by the shatter-proof glass? If I if I do the stone plating to this glass slab, then there might be a chances this glass will broken into a pieces. Okay, so what they do that this polyvinyl butyryl, they form a very thin layer of polyvinyl butyryl and they make a small hole. Okay, and these two glass will be stick in between, means this PVA will be joined these two glass. Okay. So when you plate any stone or any material that fall on that particular glass panel, okay, the glass panel can be little bit cracked, but due to the presence of this polymer, this whole glass is difficult to break. Is that clear?
Difficult to break or difficult to shatter, kind of
Difficult to
like a
shatter.
windshield. Yeah,
Yeah,
because in windshield, when we are breaking, right, all it is
yes,
some layer is gathering all the broken part.
yes. So that is your polyvinyl butyrene. Okay, that they use between this glass. Okay,
Yeah.
yeah. Next, we will study about polyvinyl alcohol. So this polyvinyl alcohol is also a vinyl polymer, and here in this we will use this vinyl acetate. Okay, we have studied in the first, that is your polyvinyl acetate. So we took this polyvinyl acetate and we do the hydrolysis process. Hydrolysis means we will remove the water and we will attach some alcohol or the OH linkage to that. That's where we will get this group. Okay. After hydrolysis, we got this polyvinyl alcohol. So the polyvinyl alcohol is obtained indirectly by the alcoholysis. Alcoholysis means here I will use the catalyst as a alcohol. Okay, of the polyvinyl acetate in the concentrated of methanol and ethanol. Methanol and ethanol are the two alcoholic substances that we use here. So here they will do the alcoholysis process of this polyvinyl acetate. So we can get the polyvinyl alcohol. The reaction is carried out in the presence of acid or base catalyst. Actually, for your quite faster reaction, we use base catalyst. Okay, we use for the faster reaction of your polyvinyl acetate to convert into your polyvinyl alcohol. So this polyvinyl alcohol, okay, contain 1 or 2 mole percentage of acetyl group. This is your acetyl group. Okay, so the percentage of acetyl group is very low as compared to your alcohol group. That is the reason, as we have more alcohol group, that is the reason it is water soluble. Okay, this polyvinyl alcohol is quite soluble in water, but it in the 35 degrees Celsius, PVA can easily soluble in water. But if we go beyond 10 degrees Celsius, means if we take the chilled water, then it takes longer period of, it takes a time to be soluble. Okay. So in the normal room temperature, this PVA will be soluble in water. But if that water, in the cold water, it will take time for the solubility. So that commonly this kind of PVA is available in the form of bead or as a solution in the water. So it can be available in liquid form as well as in the solid form. So PVA is look like this. Okay. But PVA or this polyvinyl alcohol have a very good protective colloid for the aqueous emulsion. Means this will act as a colloidal for the proper mixing, because you know emulsion, in the emulsion polymerization we have two phases. Okay, your monomer and your solvent, they are sometimes difficult for the mixing. So this PVA can act as a colloidal, okay, for the aqueous emulsion, and employed for this purpose large variety of emulsion and suspension system. So for the emulsion and suspension system, this PBA act as a colloidal solution. Means this will help to mix that two immiscible polymer. So, what is the structure property of polyvinyl alcohol? So, polyvinyl alcohol is generally atactic material.
Ma'am,
Okay.
uh,
Yes.
when we add this into, it's a water soluble, you told, like
Yes.
when we evaporate the water, again we will get that monomer, or
Yeah, you can again get the PVA, because see, in polymer case, okay, like you, polymer is different from your no, normal common solvents or common chemicals. Like suppose if you take the salt and dissolve in the water, when all the water will be evaporate, you can't find the salt, right?
yeah, yes.
Why? That is because there is a lot of chemistry, and
Mhm.
the bond will break there, and the bond will make a formation link with the water. But in case of polymer, is that's not happen. Why? Because we see this is M and N is written. What do you mean by M and N? Suppose here if I wrote 50 and here if I wrote 25, means 25 repeating unit of you have a alcohol group, and 50 repeating unit of acetate group you have.
Okay.
Understand? So
Yes.
polymer is a very big micromolecular chain. So it is very difficult to break. So they are dissolved in water as because we have one acid group over one alcohol group over here. This alcohol group make a hydrogen bond with your water.
Oh.
Okay,
Mm.
and that hydrogen bond is quite weak if we see the bonding between this polyvinyl alcohol. Okay,
Mhm.
that is a very different concept we study, in that is known as your cohesive energy density. Okay, the
Mhm.
cohesive energy density, if you know well, then you can, it's very easy for you to predict which polymer will dissolve in which particular solvent. Okay,
Cohesive energy.
density.
Okay, ma'am.
Yeah, and that is a very big concept also. So please forget that about. So if this polyvinyl alcohol is soluble in water, if the water will evaporate, then we can get our PVA. Okay.
Okay, ma'am.
Yeah. This polyvinyl alcohol is atactic in material. Atactic means we have that exhibit amorphous, around 80 to 85% of amorphous character. This polyvinyl alcohol is there. See, very common thing I will help you to know how you identify which polymer is amorphous or more crystallinity. See, if you got very random structure, means if you remember the structure of polyethylene, okay. So in case of your polyethylene, you have a very, you can't find this kind of bulky group. You have only carbon hydrogen and it has a very long chain, right? So the structure of the polymer is quite stable. But when we are studying this vinyl polymer, you remember that, see, if you look into this, there is a very small group. Okay, if you go into this polyvinyl uh, uh, acetals, here the group is increasing. Next, if we'll go into this polyvinyl alcohol, the group or the functional group, this is known as your functional group. Okay, this functional group is quite wider. Okay, uh, just excuse me for a minute. हाँ भैया, हाँ भैया, हाँ भैया बोलिए ना। मैं लेक्चर ले रही हूँ भैया। हाँ, हाँ, hello. Yeah, sorry for the disturbance. So this polyvinyl alcohol, that if you see the structure is increasing, so the perfect arrangement we can't expect. That is the reason they exhibit amorphous character over here. And there the tensile strength and the flexibility, they have a high tensile strength because they have here the presence of this group. We can have a high tensile strength as compared to your acetate, polyvinyl acetate, but polyvinyl alcohol is quite flexible. Okay, and as I told you, it is soluble in water and has no odor, means no foul smell, or it doesn't have any odor in nature when it's soluble in water. This polyvinyl alcohol molecular weight is range from 26,000 to 30,000 gram per mole. This is the molecular weight range. And the melting point, it has a very high melting point, that is 185 degrees Celsius. And as well as it is insoluble in many organic solvent. Organic solvent means acetone, IPA, that are the organic solvents.
Ma'am,
Okay.
in previous
Yeah.
3-4 cases, you have not specified about molecular weight. Is this any this thing that it's having a very high weight, or this is the average weight of all the polyvinyl?
No, not. I can't say this is the average weight. Actually, see, I got this polyvinyl alcohol molecular weight I got because they will not form that tacticity. Okay. Here the difficult to form the ciliotactic and isotactic. That is the reason I gave you this molecular weight. But when this tacticity will form and they are majorly contribute to their polymer property, it is very difficult to calculate the exact molecular weight range. Okay. So that because this I found in a very good written book, so I got a confirmation. Okay, this can be the range of this polyvinyl alcohol. That is the reason I put over here. Okay,
Mhm.
yeah. It has a melting point around 185 degrees Celsius, as well as it is insoluble in organic solvent, but slightly soluble in ethanol. Okay. But if you provide the temperature, then this polyvinyl alcohol can be completely soluble in ethanol.
Okay.
Yeah. And they have a very excellent film forming property, means easily that film can be formed and emulsifying and have a adhesive property. This PVA can be used as a emulsifying property as well as adhesive property. It is also resistant to oil, grease, and solvent. These three are very basically used in the industry, and this PVA, polyvinyl alcohol, have quite resistance to oil, grease, and solvent. all these property are depend on the humidity. Okay, that means what? These PVA, polyvinyl alcohol, are not that much resistance to your environmental stress or weather resistance because the presence of these group, they are quite unstable in the humid atmosphere. Water absorbed at higher humidity level act as a plasticizer whose reduce the polymer tensile strain but increase its elongation and tear strain. These indicate that okay presence of this group presence of this group or this group, what they will do that they will, if you keep this polyvinyl alcohol in a humid climate, okay, a humid climate of to like where there is a high humidity, means near the sea coastal region, we know the humidity is quite high. So if we keep this polyvinyl alcohol in the humid area, what this will absorb the water molecules, or this will absorb the moisture from the surrounding, and that moisture, they will act as a plasticizer. So what will do this plasticizer, we will reduce the tensile strength because they will make more soft. This polyvinyl alcohol become much soft in nature. That is the reason this tensile strength will be increased, as well as but the elongation and the tear strength will be increased in that case. So PVA generally we have to take care. PVA we can't keep it in the open places for the longer period of time. PVA fiber have a very good dimensional stability. Yes, this is a thing I want to tell that polyvinyl alcohol have a very huge application in the textile industry because this PVA fiber also have a very good dimension stability and abrasion resistance, wash easily and dry quickly. Okay, so the PVA textile have a very huge demand in the market. What happened? The fiber that we manufacture from PVA have a very higher water absorption property. Just right now only we have studied that. Okay, so due to this property, as PVA have a very higher water absorption property in comparison to other synthetic fiber, okay, uh, that is the reason they have very huge demand in the textile because the textile that is made up of your PVA fiber, they can easily soak the sweating, okay, sweat of your body, and that can you know, if you wear your cotton clothes, okay, there you know due to the sweating we feel much uncomfortable, okay, because the cotton have a less tendency to absorb the water as compared to your PVA. Though that is the reason in textile industry they are using this PVA fiber, okay, and there you can find like many of the clothes, they are using different kind of polymer also. Like you can find like many clothes, they are hydrophobic in nature. Hydrophobic in nature means if there is a spill of water, so it will be not wet suddenly. Okay. Or you know, there is a spill of
I think
coffee.
I think in
Yeah.
textile we are using that nylon also, right?
Yeah, nylon is commonly using.
Nylon is also
That
that hydrophobic, right?
nylon is not that much hydrophobic because we have a urethane group in that, urea group. So that much hydrophobic is not nylon.
Because a tracksuit, all this is a nylon kind of, so sweating is not happening, kind of.
See, that they have added two or three components because nylon is not that much hydrophobic. Okay, due to the
Okay.
presence of polar group on that. Okay.
Okay.
See this, that is the reason this PVA fiber have a huge demand in the market as they can absorb the large quantity of sweat and uh, uh, and you can't feel the awkwardness of wearing that kind of clothes. Okay, but PVA have a many other application also. PVA, polyvinyl alcohol, is also used in the manufacturing of polyvinyl butyryl and polyvinyl formal that we have recent just right now, 10 to 15 minutes back only we have studied this. Okay, then the end use of PVA include in your textile paper treatment or weight strength adhesive. These are your major application of your PVA. This is your polyvinyl alcohol fiber. Okay, that is generally used in your textile industry. So I think this like this the polyvinyl personal care and in a household product also, sorry, this polyvinyl have a very huge demand in your personal care also and eco-friendly packaging because this polyvinyl alcohol is easily soluble in water. That is the reason you can see like for the food packaging or the like they use for your eco-friendly packaging application. Okay, and PVA, okay, polyvinyl alcohol, they can use for the preparation of your contact lenses. Okay, contact lens, they are using material PVA as well as your eye wetting drop, surgical sponges, and packaging. These are the non-implant devices. As I told you, this PVA have few application in the medical also. And for non-implant device means that you can use in the external purpose, not for the in contact with our medical. This implantable device we can use like tissue adhesion barrier. Okay, tissue tearing is a very big challenges for the sport person. Okay, those who play very they like sports frequently, they are playing the sports or they have a very spirit of playing sports for very with doing hardcore exercise. So there is a very normal in the tissue tearing. One problem issue is there. So in that this PVA with some pharmaceutical formulation, they use that as a tissue adhesion barrier. Okay, and it acts as a hydrophilic coating to the cathode or lead. Cartridge replacement also. See, this application is with some formulation. Not only polyvinyl alcohol have that tendency. Okay, it might be do the copolymerization or it have a proper formulation with some other stabilizer because as you know polyvinyl alcohol is soluble in water, so might be the chances of the growth of microorganism is quite high. So that is the reason this polyvinyl alcohol will not directly applicable in the medical industry, but with by doing the copolymerization or by doing a particular formulation to that, then only we can give a proper application to your polyvinyl alcohol. Okay. So here we come across our very important, you can say, or you can say that this is your last vinyl polymer. As I told you in my previous lecture also, I will cover the very important vinyl polymer, because few of your vinyl polymer that will be you will study when you will study your polycarbonate, or when you will study your acrylic polymer, then few of your polymer will be this vinyl polymer is going to be covered. Okay. So like polymetha acrylate or the methyl acrylate, so they also come under your vinyl polymer. Okay. But that part will be covered by, I think, Pawan sir. He will take your acrylic part. I he will give you a details overview of the structure as well as property. So we will study about that polytetrafluoroethylene. That is short form we call as a PTFE. So if we take to the structural, these are the monomer, and the monomer contain carbon CF2. CF2, that is your double fluorine. Okay. And this, due to the presence of these two fluorine, this PTFA have a very, like I can say that it's have a 80 to 90% market is covered by this PTFE polymer, because you can consider any one industry or any one application that is not applicable for PTFA. This is, I can say you, this is very superior polymer, or very, we can call this polymer as a engineer polymer. Okay, because it has a very huge demand in the market for the multi-purpose application. So actually, this polytetrafluoroethylene is a have a very good story after the World War II. Okay, after the finish of the World War II, one of the scientists who is working, what he have done this chlorofluoro CF2 is a one kind of gas. Okay, uh, this gas he kept in this cylinder, all those nitrogen, oxygen, all that gases, they come in a cylinder. Okay. So he kept these CF2 gases in this particular cylinder. Okay. And next day when he come, what he saw, that the pressure drop in that particular cylinder he observed. Okay. And that particular scientist is working in this particular company that is known as your DuPont company. This is a very reputed company, US based company. Okay. So in that, when he try, he like, if I have not used this gas, then how this pressure has been reduced. So when he tried to move this cylinder, he find like nothing is moving, and it's become so tough. Then he cut that cylinder, then he found a very white color solid. Okay. And that is quite shining in nature. So then he came to know that, and that this DuPont gave a trade name to this PTFA that is known as your Teflon. And you also know, like this Teflon have a very huge application in any industry. Okay. So this PTFA was discovered in 1938 by Roy Fulkett, an American chemist, who is working under DuPont at a numerous and company. Right now, this company name is DuPont Company. Okay, different.
Madam, for your information, actually, DuPont has been taken over by Celanese.
Uh, right now,
Yeah,
I
actually,
don't.
I'm working in Celanese. We have acquired
Oh,
DuPont right now, 1 year before in
oh,
2023.
okay. But as I know, this PTFA has been invented or discovered by the DuPont company. Okay, and they only gave this trade name as a Teflon. So many people they know this PTFA on the name of Teflon. Okay, so this Teflon will polymerized into this tetrafluoroethylene. That is the monomer that is polymerized into your polytetrafluoroethylene. Who found that tank of gases refrigerated had polymerized to this white factor. This is already I have told you. So this Teflon can be polymerized with the redox initiators such as hydrogen peroxide and ferrous sulfate. This is the initiator they generally use to polymerize your polytetrafluoroethylene. So what are the major, if you see, what are the major property this polytetrafluoroethylene have? So in that, It is manufactured by free radical polymerization mechanism. Okay, it follow the free radical polymerization mechanism in the aqueous media by the addition of tetrafluoroethylene in the batch-wise process. Uh, and this is they have a very uh, the structure of this tetrafluoroethylene, okay, is quite they are highly regular structure, and this 13 helix, it is the name of your conformation that this polytetrafluoroethylene means. Suppose the polymer, whatever the polymer we have, they have a particular structure. So we have to name that structure. So the Teflon, they have the structure that is known as your 13 helix. This is the structure that polytetrafluoroethylene carries. This is a linear polymer with no branches. Means you can't find any kind of branches. This is fully linear. So as I told you, as they are very linear, okay, that is the reason they have very highly crystalline. Understand? And the crystallinity may be of like 80% to 85% of crystallinity is present due to their linear structure, as well as they have a helix structure. Helix structure means like this. It is in the rotation kind of structure, and they are bonded with very strong intermolecular forces. That is the reason they are highly crystalline, and they have a very high, as compared to many polymer, this Teflon or this polytetrafluoroethylene have a very high melting point, that is 330 degree Celsius. Understand? And uh, this mechanical strain is also quite high, and the mechanical strength of the Teflon will not change if we heat that polymer minus 100 to 350 degrees Celsius. Okay, means Can you see the how this Teflon is flexible from -100 to 350 degrees Celsius? Between this temperature range, this Teflon is quite stable. We can't change the mechanical property of this Teflon in this uh, uh, temperature range, -100 to 350 degrees Celsius. Okay. Uh,
Ma'am, one question. When we are saying melting point is 330 degrees Celsius, and at the
hmm,
same time we are saying that mechanical strength unchanged at a temperature of 350 degrees Celsius.
hmm,
So
hmm, hmm.
how like it is happening?
See, uh, this I gave a range because melting temperature will reach around 330 degrees Celsius, but these have a range like 330 to 380 degrees Celsius, the Teflon melting temperature. So directly they will not convert into a viscous fluid. Okay, there is a steps of converting from directly into the fluid state because as they are highly crystalline in temperature, when I will provide the temperature, the crystallinity phases that is present in that polymer, they will not suddenly they are going to change into the liquid. Okay, so that is the reason I can say you that in -100 to 350 in this particular range, it is mechanical strain will be not affect.
And what will be the glass transition temperature for Teflon?
Teflon will be below -100 degrees Celsius, and that will be, I think, -125 or something.
Okay, ma'am. Thank you.
Yeah. See, here we find the glass transition temperature in below 100. The reason behind that is that they are highly crystalline in polymer. If you have high amount of crystalline nature or you have high amount of crystalline percentage, okay, then you might be seen that your glass transition temperature is quite below. Means it will be below like -50 or -60, right? Because we can't have that much amount of amorphous percentage, because if you have more amount of amorphous percentage, then only you can see they have a proper glass transition temperature. Otherwise, if your material is highly crystalline in nature, then it's quite difficult to find out the glass transition temperature of that polymer. Okay, they have the they have the TG value, but that is not prominently you can get by using that DSC characterization or DMA characterization that we generally do to get the find out the TG value. Okay,
Okay, ma'am.
and yeah, this Teflon, it quite strong. Okay, uh, that is very difficult to dissolve in very strong acid also. And the strong is how much even nitric acid, okay, or the nitric acid fumes also not going to affect this Teflon. They are that much acid resistant. Okay, they will only dissolve or that property is going to be affect only when this molten alkyl metal where react to some extent. Means only molten alkyl metal, if that fell upon the Teflon, then there might be chances your PTFE can be dissolved into some extent, but that is the reason Teflon bottle also used for keeping acid. Okay, very strong acid like hexafluoropropanol. Hexafluoropropanol is a very strong chemicals that can dissolve like 80 to 90% of your polymer. So that is also not going to affect on this Teflon. Another one is your hexafluoroacid. Okay, HF. You know, HF is a very strong acid as compared to your other. So that is also quite resistant. That is also resistant for this Teflon. But as well as they have a low dielectric property. But this Teflon have one limitation that they will very difficult for the recycling. So on the point of recycling, this Teflon is very difficult for the recycling as they can recycle but only in terms of mechanical. Okay, but they will not recycle by your chemical process because it is almost resistance to 80 to 90% of the chemicals. Okay, so when it have a very high resistance to the chemicals, then they are not going to be recycled by your chemical method. But yeah, they can recycle by your mechanical, but for that also you need very strong blade formation. Okay. Uh, they have low dielectric property also. See the dielectric property, if you see in many of this polymer, I gave you this dielectric property. What do you mean by this dielectric property and why this dielectric property is important for us? Dielectric is what? It is like conduction, right? Conductivity. Insulation properties, where there is a no flow of electrons. Okay. So the charge will not occur there. Conductive. Conductive means the electron will be flow and that can generate your electricity. But what do you mean by this dielectric? This dielectric is what? When you provide some external electric field to that, then your free electrons that is present, they will start the transport take place. Then your chances is that then your electricity can be generated on that way. But dielectric, the the air we breathe, they have also some dielectric properties. Okay. So due to this Teflon structure, if you see this Teflon structure, we can't find any kind of free electrons present in this. That is the reason they have a very low dielectric property. Means if I can use this Teflon for building some insulation cables or anything where you can use like because Teflon is a quite chemical resistance as well as they have the low dielectric properties also. So they are quite showing a very quite interesting insulation property to the electricity. Another problem with the Teflon is that they are quite difficult for the processing. You know, uh, the processing technique we use for the manufacturing of polymer can be of injection molding, or we can say that we can use extruder, everything. Okay. And flow property of a polymer play a very important, okay, and this flow property we generally measure as a MFI, okay, melt flow index. So if due to this perfect arrangement and due to this perfect highly crystalline in nature, it is very difficult for this Teflon to do the processing. So the Teflon processing required very specific instrumental facility is available. Okay, this Teflon come on that present in the market in the beads or in the form of powders. Generally, they available in the form of very fine powder. Okay, so that powder they can provide little bit they provide the temperature into that and then they form lot of molded to that mold or what kind the requirement kind of product or the final product you want to achieve that you can get by a very specific techniques that they use for the processing of Teflon. In general, what I want to conclude to this point is that Teflon processing is quite difficult and you need very specific instrument you need for the processing of this Teflon because they have a very low flow properties. Is that clear? Okay. But you heard that uh, uh, many cooking utensil that we use and we are very fond of that is your non-sticky pan. Okay, so the non-sticky pan, if you see the upper portion of that pan is covered or that one film form of your Teflon. Okay, so they have very low energy. That is the reason they are non-sticky in the surface. For non-sticky, this Teflon have a very huge demand. All the non-sticky pen that is available, they use this Teflon. Okay. But you know, this non-sticky pen, if you don't purchase or if you don't buy a good quality of non-sticky pen, then after 4 to 5 washing, this Teflon, while we do the washing, and after that again we are cooking on that same pan, might be chances is there a few of the micro particles of your Teflon that will also go to or that also we consume along with our food. So it is recommended always that this non-sticky pan we should not use for a longer period of time. Okay, they have a limitation of washing to that, or we should not wash this non-sticky pan with in a very harsh manner. Okay. And here, if I want to tell the density, the PTFE have a density of 220 kg per meter cube. And the PTFE is, as I told you, it is a multi-specialist polymer. It have a very high weather resistance as well as UV resistance as well as corrosion resistance. So this PTFE material, if you kept or if you use them for your outdoor application for a longer period of time, still you find they will not damaged. Why? Because quite they are quite resistant to the UV as well as corrosion or as well as weather. So due to this property, this Teflon have a very wider application. So what are the application this Teflon has? Teflon have a very wider application in your automotive industry as well as your aerospace technology, food processing industry, petrochemical industry, defense application, electrical, chemical, and especially in the biomedical and pharmaceutical application. So, what are that application? We will know each application little bit in details. Uh, this PTFA, we can use them in the coating format also. So while in the cooking pan, okay, that non-sticky pan we used for the cooking purpose, there this Teflon, they use them in the coating form. So this PTFA used to coat a variety of items, including your pans. Pans means the cooking pan, bearings, and your outdoor panels. You know, bearing that is used in your automobile industry, okay, or different kind of bearing is available in the market for it's depend upon the I don't have that much knowledge about the bearing, but I saw the bearing there. You can see one white color, one round will be there. Okay, so that is of your Teflon. So on above the bearing also they are spray with the help of spray gun. They are coating this PTFA for the longer or the sustainability of that particular bearing. And in the outdoor apparel, also they are doing the PTFA coating. PTFA coating also used to prevent insect from climbing the wall and geckos from the sticking to the surface. Okay, so for in the few of the walls, okay, where majorly your hygiene is required, they are using this PTFA coating because PTFA is highly hydrophobic in nature as they are the cohesive energy is quite high for the Teflon. They're highly hydrophobic. Means this hydrophobic is around 120 to 125 degree. That much contact angle we have for the Teflon. That is the reason they use this in the coating. So no insect also can remain there. That much hydrophobic is this. Then, as I told you, they have a very low dielectric property.
What is the
That
relation
is the,
between insects, please?
see, if, okay, when your insect is attracted to that place, when you have like some water or some food that is required for that insect to grow, okay, if that is present in that particular place, then your insect will grow or that insect is attracted to that places. So as this Teflon have hydrophobic means if you spill the water within the second or within the second, all the water will come out. Okay. And if you see the Teflon have a very oily kind of texture, means they are quite smooth in the nature. So if this insect they try to climb also there, actually, that is a mechanism because when insect is climb on that particular wall or anything, there is a contact between this wall and the leg of your insect. So that also come in contact of the one property that is known as your surface energy. Okay. So as I think I have mentioned over here, sorry, I didn't mention, but this Teflon have very low surface energy. I didn't mention. Sorry for that, but this Teflon have a one very special quality that is they are they have low energy or the low surface energy. So when the insect try to climb due to the low surface energy, the insect can't able to climb, and that is fully a concept of like surface energy and the leg of that insect. Okay. Uh, if I will come across to your electrical insulation property, as I told you, this Teflon is low dielectric. So we use the Teflon for the electrical insulation or to protect electronics components. Okay. In medical field, it has a very huge demand as because once this is hydrophobic in nature means no that water is not going to stick in that particular material for a longer period of time. Okay, in that case, what will happen? No microorganism growth can be occur. That is the reason here this PTFA have a huge application in the medical, such as they can that can be used for the catheter, syringe, or the biocontaminated vessels. Especially, PTFA is also used as a coating on the catheter to prevent the bacterial and the virus infection. Okay, as due to they have high surface energy, sorry, low surface energy. Low surface energy means high contact angle. High contact angle means they are hydrophobic in nature. So due to that property, this PTFA they do the spray coating to the catheter to prevent the bacterial or virus infection. Okay, these have a very huge demand in the chemical industry. Why? Because as I told you, if you see to this property, okay, what that no dissolve any strong acid. Due to this Teflon have a very high resistance towards your many chemicals. That is the reason in many chemical industry, this Teflon is used as a gasket, vessel lining, and in the chemical tanks. Understand? And the chemical industry or any research in any R&D labs or wherever there is a research in some acid or you can find everywhere they are using the Teflon vessels. Okay, they are quite lifetime protecting. They are quite chemical resistance free. The mechanical strength is quite good on that way. So due to all those property, they have a very high demand in your chemical industry. Next, food and drinks. Okay. So PTFA is used in food and drink production for cooking equipments, food covering, conveyor belt. Okay, you know where there is a very larger production of food. Okay, actually PTFA used in the food industry like your roller that they use where they mixes the wheat flour dough or where the mixing is happening in any food industry, uh, they use the roll, okay, as like our two roll meal. In the food industry also have the two roll meal, but that two roll is of your PTFE. Why? Because this they know that not any food is going to be stay in that Teflon, so no contamination will be occur. If there is no contamination, then that thing is quite better for your food industry. And conveyor belt roller also they use that. Then the temperature sensing caching. So these are the few of the Teflon equipments or the components that is majorly like installed in the food industry or the beverages industry where the larger amount of production or the continuous amount of production is happening only due to the uh, properties of your Teflon. Next, what is happening here is that they use in the solar panel also. But solar panel have, if you see the white lining between the two solar panel, okay, if you see that small white color lining between, not not in the mid of that panel, but in the side of the panel, they are the PTFA. Why? Because this PTFA, we know they can withstand to temperature of to 260 degree in the outdoor. Outdoor, I am saying that they can withstand to, we know that temperature they can withstand that is up to 350 also. That up to that PTFA is not going to affect. Okay, so due to that property, we use them in the solar panel also for increase the lifetime of this solar panel. Okay, so thank you so much for your attention. If you have any questions regarding your vinyl polymer that I have discussed, you can ask me.
Ma'am, can you go to back slide, please?
Yeah, backslide means
Yeah, this one, yeah.
it's
Here it's last
yeah.
line can withstand. After that, unable to see is some thing is hidden.
Uh, yeah, I can see you. It can, I will read you for you. Okay. It
Okay.
can withstand temperature up to 260 degrees Celsius.
Because I think other people also can't able to see maybe some because I can
Okay,
able to see. Yeah.
it is written that
In full screen, you can
heat.
visible. If bottom this thing is coming up, it is getting hidden.
Okay, so I have to go to
Oh,
full screen. You mean to say?
Yeah, in full screen it's visible.
No, full screen also not visible.
okay, I will read out for you. Like PTFA is used in the solar panel manufacturing because it can withstand temperature of to 500 degree Fahrenheit, or that will convert into 260 degrees Celsius.
Thank you, ma'am.
Yeah. And as I told you, because if I'll go to my first slide, yeah, this slide. See, this acrylite portion, okay, this much will be taken by Pawan sir, as he will teach you about the acrylic polymer, okay? And uh, everything I have touched over here, and I will teach you the polycarbonates and everything in my coming lecture. Okay? Anyone have doubt, or we can
In the
conclude
injection
this?
molding process, only polymer and copolymer come into picture, or even monomer directly used in the injection molding.
No, we can go for only polymer. We can't go for monomer
Only
because
polymer and
that, yeah, only polymer.
okay. And compounded
Uh,
polymers, call it as copolymers, huh?
yes, right. Master batch, you got na compounded wala.
Okay.
So you can do in the extruder that one.
Yes,
Then
yes.
what we mean by master batch? Can you elaborate, please?
Master batch means suppose you are purchasing polymer. You saw that that polymer have already color. Okay, blue color, yellow color already. In that polymer, you have already, they have added heat stabilizer, antioxidant, flame retardant. As for your application, all additives has been mixed. The color of that particular polymer they have added, or if you want to do some copolymerization to it, everything you got. That is known
Yeah,
as your master batch.
basically sample, right? Sample of the
Yes,
part.
yes. Yeah, you people say that as a sample. We call that as a master batch. And that you just do the final processing. Suppose in the injection molding, you do the final processing to get your product.
But
Yeah.
master batch will be a solid type, right? Solid,
Yeah, it is in the solid granules
solid
form.
sheet type.
Seed, seed granules, whichever form you want.
So because generally in injection molding we are giving input as granular only.
Yeah, granule, powder. Powder also we get.
Okay.
Yeah. Any else from the class?
Can we go to the first slide with all the polymers in one this?
Okay.
Um, here there is a only last three it will be taken care by the other professor. From today, today is your last class, ma'am.
No, I will take polystyrene, polycarbonate in details in my coming lecture.
Okay.
Tomorrow I will take your polycarbonate lecture.
Okay. But here we call it as a vinyl group. But in polymer, right side, if we see it is polyethylene, polypropylene and all. So all are vinyl
Yes.
group.
Yes, all these polymer come under your vinyl polymer because the monomer have this vinyl substituent. Can you see that I have highlighted in color?
So H2C,
Yeah,
H2C is vinyl.
yeah, this is your vinyl group. In whatever monomer, if you see this is present, then that is your vinyl polymer. Means whatever you are getting the polymer from that.
And if there is a double bond, we get this is an addition polymer, additional polymerization.
Maximum vinyl polymerization will go into the addition polymerization.
Okay.
Yeah.
What is that in vinyl group? What is R? What do you mean by R?
R, see, this R can be your methyl acrylate. This is your acrylate person. Here, this is your styrene. Here, R means CH3. Here, R means your pyrrolidine. Here, R means caprolactam. Here, R means OH. Here, R means chlorine, acetate.
R means
Uh,
reactant group. You mean to say?
yeah, yeah, that is your reactant group. These are the R.
Okay.
It's like functional group, huh?
Yes, functional group.
Okay. Okay.
But for your polymerization, this will be take part.
Mm-hmm.
This group will take.
Polymerization, this R portion will have a chemical reaction and vinyl portion will have a this thing like bonding and other things. Huh? How it is, ma'am? Both will have the chemical this thing, or it's only the temperature and other thing also plays a role, no? Here.
Yeah, temperature, everything will play a very important role. See, if you see the structure of polystyrene, what you are seeing that here the attachment is there. Okay, another C will there, HH there. So this will be your monomeric unit and this will going to be continue, but this part will remain as it is. So that
Okay.
is the reason I told you the double bond will take part in your polymerization process. Because the double bond is there, na? That's why you do the free radical or the addition polymerization is there.
So vinyl is only have is creating the this thing.
Linkage with the another uh, oligomers.
Okay, okay. So vinyl is creating linkage and the other part is continuing.
They are, yeah, they will be like that only. Okay. And that is the reason they due to that functional group. Actually, if you look into this, okay, I'll go to this first line. This is your functional group. Okay. And this will decide it the properties of your polymer.
Okay, okay. But
And
in
according to property, we have a application.
this, if we see this H2C, okay, this is only one link. That is why it is like this. If it is continuing, means everywhere the H2C will continue. It is like,
Yes, yes, yes.
okay, 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 ma'am. So this other than H2C will remain same. This H2C will break, double bond will break and it will continue.
Yeah, it will be continue.
Understood, ma'am. Okay.
Hmm. Okay.
Okay, ma'am.
Yeah. See you for the tomorrow lectures. Okay.
Thank you, ma'am. Thank you.
Yeah. Thank you so much.